Let's apply Green's theorem to evaluate the integral y minus sin x dx plus cos y dy along a closed curve. Once again, we want to apply Green's theorem to evaluate this integral y minus sin x dx plus cos y dy along a closed curve, which is the closed curve bounded by the boundary of the triangle, closed curve formed by the triangle y equal to 0, x equal to pi by 2 and y equal to 2x by pi. Once again, y equal to 0, x equal to pi by 2 and y equal to 2x by pi. So of course we should draw this triangle and we have x-axis. Y equal to 0, no problem. That's the line y equal to 0, that lie on x-axis only. Then we have x equal to pi by 2. X equal to pi by 2, that's a straight line. X equal to pi by 2, well done. We have the line x equal to pi by 2. Then lastly we have y equal to 2x by pi. Let's draw the line. It must pass through the origin y equal to 2x by pi. Y equal to 2x by pi. So we have the line y equal to 2x by pi, x equal to pi by 2 and y equal to 0. Now let's label this triangle as triangle OAB. So we want to evaluate Green's theorem over this triangle OAB. When we say Green's theorem, of course we need the closed curve or the area. We are given closed curve. Now we exactly know the closed curve. That closed curve must be the triangle OAB, and let's start from the point O. Let's move up to A, OA, then from A to B, then lastly from B to O. So of course we can evaluate along this closed curve from O to A to B and B to say O. We can evaluate this line integral, no doubt about it, but it will be bit difficult. That's why we have been asked to apply Green's theorem. Let's apply Green's theorem then. Let's state the formula. By Green's theorem, we have integral over a closed curve f1 dx plus f2 dy, integral over closed curve f1 dx plus f2 dy equal to integral over region. Well, region in our case is triangle OAB, integral over region, that is in our case is triangle OAB, del f to del x minus del f1 del y dx dy or dy dx. We prefer dy dx. You can do dx dy as well, no problem. Now, but we are given closed curve and we are given some integral y minus sin x dx plus cos y dy. Let's write that integral as well. Integral over closed curve. We are given integral over closed curve y minus sin x dx plus cos y dy. That is given. But the formula says integral over closed curve f1 dx plus f2 dy. But to do that, we should choose f1 equal to y minus sin x and f2 equal to cos y. Once again, we should choose f1 equal to y minus sin x, f2 equal to cos y. Let's choose it. f1 equal to y minus sin x and f2 equal to cos y. Equal to cos y dy. Now, as we have said earlier, instead of evaluating from O to A, then going up from A to B, then returning over from B to A, O, it will be much easier to evaluate the right hand side. So we should compute del f2 del x minus del f1 del y. Let's compute it. Del f2 del x del x minus del f1 del y. Del f2 del x minus del f1 del y equal to del x of cos y minus del y of del f1 del y. F1 is y minus sin x. Del x of cos y is just 0 because x and y are independent of each other, and in case of partial derivative, if they are independent of each, x and y are independent of each other, and if you are applying partial derivative of two independent quantities, that is always 0. We just regard y to be a constant. Minus del y of y is 1. Once again, del y of sin x is 0 because when you are partially differentiating x with respect to y, then those two quantities being independent, you treat x as a constant, so this is 0. So del f to del x minus del of 1 del y is just minus 1. Therefore, integral over region, the region is your triangle OAB, del f2 del x minus del f1 del y dy dx is just equal to integral over region. Let's write region once again. Triangle OAB. Del f2 del x minus del f1 del y is just a pretty simple number, minus 1. We love it. Minus 1 dy dx. So easy now. Oh, lastly, we just need to, what exactly is the triangle OAB? What exactly is the region triangle OAB? Let's look at the figure. We want to cover up the triangle OAB. Let's zoom it out. We should start from the line OA and go up to OB. Once again, we should start from line OA, then go up to OB. Well, then we can go this. We'll be covering this region as well, but we don't want that. Okay, first we should start from y equal to 0 and go up to y equal to, we are given 2x by pi. But then we will be covering this region and also maybe this region, which we don't want. How do you remove those which you don't want when you change y equal to 0 to y equal to 2x by pi? Well, simple. You change x from x equal to 0 to x equal to pi by 2. That's also given to you. The equation of line AB is x equal to pi by 2. Then you will be exactly covering the triangle OAB. You will be exactly covering the triangle OAB if you change y from y equal to 0 to y equal to 2 pi by x, 2x by pi. If you change y from y equal to 0 to y equal to 2x by pi, then from x equal to 0 to x equal to pi by 2. That will cover the region formed by triangle OAB. So let's write it down. We'll cover the triangle OAB if we change x from x equal to 0 to x equal to pi by 2 and y from, let's write y small, y from y equal to 0 to y equal to 2x by pi. And you have del f to del x, that's your triangle OAB. That's exactly how you can curve a triangle OAB. And you have minus 1 dy dx, that's copied as it is. That's del f to del x minus del f on del y, that is minus 1. So we are almost done now. Yeah. Integral of minus 1 with respect to y is integral of minus 1 with respect to y is minus y, sorry. So x is changing from 0 to pi by 2. Y is changing from y equal to 0 to 2x by pi. Integral of minus 1 is minus y. Y is changing from y equal to 0 to y equal to 2x by pi. So if we write those values, y is changing from y equal to 0 to y equal to 2x by pi, then you get minus 2x by pi dx. Lower limit y equal to 0 should be right. Let's just write minus 0 for the sake of completeness. We need not write as well. So this is equal to minus 2 by pi. That's we can take it out. That's a constant number. Integral of x is x squared by 2. And we need to change x from 0 to pi by 2. When we do that, we have minus 2 by pi into your x is pi by 2, whole thing is square, pi by 2, whole thing is square, into 1 by 2. Well, we can cancel 2 and 2. Pi square and pi can get cancelled, and you are left out with minus pi by 4. That's it. Of course, you can try to evaluate the left hand side of Green's theorem. You can try to evaluate along the closed curve y minus sin x dx plus cos y dy, but you need to do it 3 times and it will be pretty long. If you get the answer, very good. We don't need it though. We have been asked to apply Green's theorem and calculate the integral, so we have calculated and we are done. And we got the answer equal to minus pi by 4.